Hi there, this is still section 9.2 for Math 148, our business calculus, and I'm looking at question number 25. Still looking at limits. The question says use the analytical method to evaluate each limit, and then what does the result tell you about the horizontal asymptotes? So question 25, here's the question. I don't want that, I don't want you. So we want the limit as x goes to infinity, and this is positive infinity. It's always funny to think of positive and negative infinity because infinity is sort of endless, but you could be endless in the positive direction or endless in the negative direction. So here's the question. You want the limit as x goes to positive infinity of 3 divided by x plus 1. Well, this is a bit of a mess, but here's how you do it. Here's the tricky thing. You divide everything by 1 over x. Why would you do that? You just have to trust me. So we're dividing top and bottom by 1 over x. This doesn't change anything because 1 over x, that was a weird x, divided by 1 over x, that's the same as 1. So we're essentially doing that algebra trick where you multiply top and bottom by the same thing, so it's the same thing as multiplying it by 1. Anyway, we do that because now we have 3 divided by x all over, wait for it, so this is x over x, and this is a little baby step, you probably won't do this, times 1 over x, because it's 1 over x times x, and 1 over like that. So this is equal to 3 over x divided by 1 plus 1 over x. So we haven't really done anything except change the form of the problem, and this is the reason we did it. So the limit of all this, as x goes to infinity, now we use our rule, this thing, I'm going to use a different color for fun, that goes to 0 because x is on the bottom. Why does that go to 0? Well, there's a rule, flip. It's on page 561, the limit rule. Or you can just think, oh, when the x is on the bottom, it goes to 0. That one goes to 0. And now we have 0 on top over 1. Okay? Which is equal to 0. So that's the analyzing it analytically, is that it's 0. But what is this telling us? So we're saying analytically we just proved that the limit as x goes to positive infinity of this whole thing, 3 divided by x plus 1, is equal to 0. So as x goes to infinity, this function is approaching 0, and this is what it looks like on the graph. So here it is, 3 divided by x plus 1, wait for it, graph. Pacha! That was the noise it made when it graphed. So as x goes to infinity, so here's x right here, as that goes up to infinity, then you'll notice it's going towards 0. It's getting really close to 0, but it's never getting to 0. So that is what part B is asking us. Part B of this question says, what does this tell you about the horizontal asymptotes, which is a hard word to say and a hard word to spell, but it has a tote at the end. I think mathematicians should carry around asymptotes. Wouldn't that be cute? So here it is. We know that there's a horizontal asymptote at y equals 0 because the limit as x goes to infinity is 0, so that tells you there's a horizontal asymptote at y equals 0. And here's what it looks like on the graph again. Here's this green line is y equals 0. So you can see it's approaching y equals 0. I can make it a blue line if you like. Do you like that better? It's not much better. Anyway, don't get distracted by this line. That's the vertical asymptote. We're not interested in that right now. So that's how you solve this problem. You say this, the limit is 0 and there's a horizontal asymptote at y equals 0. And now I will also look at question number, I'm trying to find one that's a little bit different. How about 31? 31, hold on. Section 9.2, question number 31. Still looking at evaluating the limit and finding that asymptote. So, the limit as x goes to infinity, did they mean positive infinity? They may have said that, I just didn't write it down. In my mind, infinity means positive infinity. Yes, they did mean positive infinity. As of 3x squared plus 5x all divided by 6x plus 1. So we're going to do that same trick where we multiply top and bottom by, in this case, we're going to multiply everything by 1 over x squared. Like imagine this as a large number 1. Everything's 1 over x squared. Why did I choose 1 over x squared? I did 1 over x last time. It's because now the highest order is x squared. So in this case, we're going to multiply everything by 1 over x squared. You essentially look through the problem, and whichever is the highest power, pick 1 over that. So now this is equal to the limit as x goes to positive infinity. It's positive infinity. It's so good. It's 3 times 1 over x. Sorry, 3x squared divided by x squared. This is adding a step that you guys probably won't do. 5x divided by x squared all over 6x divided by x squared plus 1 divided by x squared. This is fun. Equals what limit? I always like to write this. Let's be all pure and mathy. Of, those cancel. So that's 3 plus, I'm going up here. Oh, that's a 5 over x. All divided by, that's a 6 over x. Plus 1 over x squared. Okay? And some of you are thinking, that's no good. That doesn't look any better. But here's why we did this. So this is the limit as x goes to positive infinity. So when you plug in zeros here, you go, well, use a different color pen. This one, x on the bottom, it goes to 0. So all this, that's actually not a limit, is going to be 3 plus 0 on the top. That one goes to 0. That one goes to 0, divided by 0. So that's 3 divided by 0, which is no good. I'll make a big no good. You can't have the mathematical limit be divided by 0. So this tells us, 3 divided by 0, that the limit does not exist. And that also tells us that there is no horizontal asymptote. Horizontal asymptote at x at infinity. So I will show you this on the graph. Again, remember, if it's 0 divided by 3, that would have been fine, but now 3 divided by 0 is no good, so limit does not exist. So remember, they were asking you to evaluate the limit. Well, you can evaluate it like this by saying the limit doesn't exist. That's acceptable. So going here, I'm going to put this into the graph. Wait for it. Okay, so here it is. 3x squared plus 5x divided by 6x plus 1, graph it. Wah! Okay, so we're saying what happens when x gets bigger. Let's zoom out. This asymptote gets kind of weird on this graph, but as x goes to infinity, you'll just notice this gets bigger and bigger and bigger. There's no limit, there's no horizontal asymptote, so there's no line. If I had a ruler, there's no line I can draw where you say, oh, look, the red line's never, see, that would be like a horizontal asymptote, but it's going to cross that line. So there's no line you can put here where you think it's never going to touch it. So there's no horizontal asymptote. Again, don't be distracted by this vertical asymptote. There's a vertical asymptote, but no horizontal. Horizontal's like a ladder. It goes across that way. So that's how you do those problems. Limit does not exist, no horizontal asymptote, and I will not ask you to graph on your test, so don't worry too much about the graphing. I just put that in there for joy. Joy, joy.